Betelgeuse, the colossal deep crimson supergiant anchored in the shoulder of the Orion constellation, has fascinated humanity for centuries. Its vibrant scarlet glow and sheer enormity have made it one of the most recognizable stars in the night sky. Astronomers often remark that if Betelgeuse were to replace our Sun at the center of the solar system, its outer layers would stretch well past Mars and possibly as far as Jupiter's orbit, swallowing the inner planets entirely. This staggering size alone marks Betelgeuse as a star in the final chapters of its life. Like all red supergiants, it is living on borrowed time, heading toward an inevitable and violent fate, a supernova. But in recent years, Betelgeuse has been acting strange. Its luminosity, which for centuries has been fairly steady, has undergone dramatic swings. At one point, its brightness surged more than 50%, propelling it from the 10th brightest star in the sky to the 7th. This unexpected leap caused a stir among scientists. Was this the first tremor before the grand finale, or simply a temporary fluctuation in its natural rhythm? The stakes of that question are enormous. If Betelgeuse were to go supernova, its brilliance would likely be so intense that it could rival the daylight, a celestial display not seen in recorded human history. Such an event would not only captivate the public but would also offer astronomers a once-in-a-lifetime opportunity to study the death of a star in exquisite detail. A star's apparent brightness depends on three things: size, temperature, and distance from Earth. Betelgeuse has all three factors working in unique balance. It boasts a diameter over 700 times that of the Sun, yet it is much cooler on its surface, around 3000 Kelvin, which gives it that signature reddish-orange hue. This combination makes it an ideal candidate for a spectacular end, and its erratic recent behavior has only added to the anticipation. Then came late 2019. Betelgeuse shocked observers by dimming to just 40% of its usual brightness, a change so significant it was obvious to anyone looking up, even without a telescope. Theories flew. Some astronomers suggested that a cloud of cosmic dust had temporarily veiled the star. Others speculated that changes deep inside Betelgeuse had caused the dimming. The possibility that this was the last breath before a supernova became a serious point of debate. Observations from the European Southern Observatory's Very Large Telescope, VLT, in Chile revealed something astonishing. High-resolution images showed Betelgeuse's surface had become visibly distorted. Follow-up analysis suggested the dimming was caused by a massive surface ejection, a colossal outburst in which the star hurled an enormous amount of material into space. How enormous? More than 400 billion metric tons of stellar matter were expelled, an amount far beyond anything our Sun has ever produced. The eruption reshaped the star's outer atmosphere and disrupted its usual pulsation cycle, cutting its rhythmic expansion and contraction from 400 days to about 200. This was a seismic shift in the life of the star, and it raised the question: how much longer can Betelgeuse maintain its stability? The physics of such an event are staggering. Red supergiants like Betelgeuse live fast and die young compared to smaller stars like the Sun. When they exhaust their nuclear fuel, their cores collapse under gravity's pull, triggering a supernova, a titanic explosion that rips the star apart, blasts heavy elements into space, and floods the cosmos with energy. When that collapse begins, the first sign won't be light but ghostly, nearly massless particles called neutrinos. These particles escape from the star's core almost instantly and would reach Earth several hours before the visible explosion. Astronomers have detectors tuned to catch such fleeting signals, ready to give the earliest possible alert. When the light finally arrives, Betelgeuse could shine so brightly it would be visible even in the daytime. At night, it could cast shadows as strong as the full moon. The light show could last for weeks before slowly fading. For scientists, this would be an unparalleled chance to gather real-time data on every phase of a star's death. To unravel the mystery of Betelgeuse's peculiar activity, researchers are turning to advanced computer simulations. These models, built using data from instruments like the James Webb Space Telescope, JWST, and the VLT, allow scientists to peer inside the star and trace the origins of its volatility. One hypothesis points to a massive cavity of gas deep within the star, disrupting its pulsations. JUIC's infrared capabilities have also revealed the complex layers of dust and gas surrounding Betelgeuse, a kind of shroud formed from its own expelled material. While most estimates still place Betelgeuse's supernova between 10,000 and 100,000 years from now, its erratic nature means that number could be wildly off. It could happen in our lifetime, or it could be many generations away. This uncertainty has prompted a global monitoring effort. No one wants to miss a moment if and when the end comes. By late 2023, JWST made another remarkable discovery. It detected signs of a rapid internal collapse inside Betelgeuse, likely linked to its earlier surface ejection. The star's once regular 400-day pulsation cycle had been permanently altered, now locked at a jittery 200-day rhythm, a possible sign of deeper instability. This shortening could mean the star is transitioning into the last stage before its core begins producing iron, the final nail in the coffin for a massive star. Here's why that matters. Lighter elements like helium and carbon release energy when fused in a star's core, which keeps the star stable. Iron, however, does not. Once a massive star starts producing iron, it's only a matter of days, sometimes hours, before collapse begins. The debate among astronomers is fierce. Some believe the changes we're seeing now could mean Betelgeuse has only centuries left. Others insist these are just dramatic mood swings in a star that still has millennia to burn. Either way, its time as a red supergiant is drawing to a close. When the neutrino detectors finally spike, the countdown to the light show will begin. And while Betelgeuse's supernova would be one of the most spectacular celestial events in human history, it poses no danger to Earth. At about 642 light-years away, it is far enough that the radiation will not harm us, though its light may keep us from seeing many other stars for a while. In a broader sense, Betelgeuse's story is about more than just one star's demise. Supernovae are the universe's great recyclers, scattering heavy elements, oxygen, carbon, iron, into space, where they eventually form new stars, planets, and even the building blocks of life. The calcium in our bones and the iron in our blood were forged in ancient explosions like the one Betelgeuse will someday unleash. Today's cutting-edge telescopes, both on Earth and in orbit, have transformed our ability to catch such cosmic events in the act. Instruments like the VLT and JWST can detect subtle changes in brightness, temperature, and composition long before the naked eye notices. For astrophysicists like Neil deGrasse Tyson and countless others, Betelgeuse represents the perfect blend of mystery and opportunity, a natural laboratory on an epic scale. So the next time you look up at Orion's belt, glance to the reddish, shoulder star, and know that you're watching history in slow motion. Whether we're seeing the final sparks of a dying giant or just another dramatic episode in a restless life, Betelgeuse is a reminder that the universe is always in motion, and its greatest shows are worth waiting for. Until the day it happens, scientists will keep their instruments trained on this behemoth, waiting for that first neutrino signal, the whisper before the roar. And when the light finally reaches Earth, it will mark not just the end of a star, but the beginning of a new chapter in our understanding of the cosmos.